Okay, so now we're moving on to chapter 6. You should have looked over the first 3 sections on your own with those self-teach packets. The exponent properties and just adding, subtracting, multiplying polynomials. There's some basic things that you should have had from Algebra 1. Now we're going to get into dividing. I'm going to teach this one myself because of I think it's a little more complicated and something that you haven't seen before. So there's going to be 2 methods of dividing. We're going to use long division and we're going to use synthetic division. Long division is basically the same steps as if you were using long division for integers. Okay? You're going to find out how many times a value goes into another value, multiply, and then subtract. The steps are going to be the same, but our problems are going to be dealing with polynomials. Okay? So look at long division first. We have x squared plus 6x minus 16 divided by x plus 8. So I'm going to set up the long division then. X plus 8 divided into x squared plus 6x minus 16. Now, the way I think about this, I always look at the first terms in both polynomials. We have x and then x squared. Okay? And I just think, how many times does x go into x squared, or what is x going to go into, or what we have to multiply by? So I always go to the side and set up this little expression. X times what will give me x squared. And this is where you need to be able to do the mental math and think about, okay, what am I going to multiply x by to get that x squared? Well, in this case, I multiply by x. X times x is x squared. Whatever you fill in the blank here goes up on top. And everything's always going to line up nice. All of our x's are going to line up, all of our x squareds would line up. Okay? And another way you can think about it, there's 2 terms out here. X plus 8, 1, 2. 1, 2. That's where our first term would go when we start setting up our answer up top. Now, just like before with regular long division, once you put a value up here, you're now going to multiply. And we're going to multiply by that whole polynomial on the outside. X times x plus 8. So it's a little distributive property. And this is why you have a little more work than if it was just regular integers. You have to take the time to make sure you do your distributive property correctly. And when you're putting it underneath, again, everything has to line up. So it's going to go x squared plus 8x, and now we're going to subtract. Now this is usually where the error comes in. You have to make sure you're subtracting. So take your time and think about x squared minus x squared cancels out. 6x minus 8x is negative 2x. A lot of times people would add those and get 14x. You have to make sure you're doing your subtraction and just bring down that minus 16. Now again, I'm worried about the first 2 terms. So I'm still using this x over here, but now I have to figure out x times what gives me negative 2x. X times what gives me negative 2x. And you should be able to figure out x times negative 2 gives me negative 2x. So we're going to have x minus 2 up there, and again we have to do the distributive property. So we have negative 2x minus 16. Everything lines up nice. All the x's, all of our constants. And again, we're going to subtract. Take your time and think about what we're doing. Negative 2x minus negative 2x cancels out. Negative 16 minus negative 16 goes to 0, so there is no remainder. X minus 2 is our answer for that one. Okay? So let's look at what we did here. You thought about the first 2 terms, and this setup over here is what I do for every one. There's going to be problems where we're going to have 3 or 4 of these set up depending on how big the problem is. So here I multiplied, set it up underneath, and subtract. Now again with the first 2 terms. Figure out what it is, multiply, and then do my subtraction. Okay? So think about these steps, and again, this setup over here is what I do over and over again. Just think, working my way down the polynomial, dividing into that value. Okay? So there's our first example. Get my right here. Here we have 2x cubed minus 4x squared minus 2x minus 18 divided by x minus 3. So I'm going to start this this off the same way. I'm thinking of my first two terms, x and 2x squared, 2x cubed. Over on the side here, x times what? Gives me 2x cubed. Okay, so again, you just need to think, x times what is going to give me that value? So x times 2x squared, okay, 2's are okay, x times x squared gives me x cubed. So that works out. Put it up top again, two terms on the outside, so I'm going two terms over. I might have to do my distributive property. 2x cubed minus 6x squared. 2x cubed minus 6x squared. That first term should always cancel out. That's what the goal is. If that doesn't cancel out, you need to go back and think about what you multiply by. So we have 2x cubed minus 2x cubed. That does cancel out. Negative 4x squared minus negative 6x squared. That's how I give me a positive 2x squared. Then bring down my minus 2x for the next term now. Same setup. X times what gives me 2x squared. So it's very similar to the first one. I'm going to multiply by 2x this time. Put my 2x up here. Distributive property gives me 2x squared minus 6x. Okay, the first term should cancel out. 2x squared minus 6x. And we end up with 2x squares cancel out. 2x squared minus 6x gives me 4x. Bring down my 18. So again, now I have to do a third one. The first example, we only had to do this setup 2 times. This time we have a third one to do. X times what gives me 4x. I'm always caring about that first term. X times 4 gives me 4x. Put the 4 here. Oh, let me do the work. I'm sorry. I tried to skip ahead there. 4x minus 12. And when doing this now, the 4x's cancel out, but this time negative 18 minus negative 12 gives me negative 6. Okay, so this time we have a remainder. You have to remember that remainder, it's a fraction, okay? It's not a whole polynomial x minus 3. So we are going to write this as a fraction. So how I would want you to write this is 2x squared plus 2x plus 4 plus negative 6 over x minus 3. And that would be my final answer. So whatever the remainder is, it'd still be written as a fraction, just like if it was integers over what we're dividing by. Negative 6 over x minus 3. Okay, so take a look. I did my setup 3 times. Okay, because we had to have 3 terms up there, just working my way down the line. And look at it. All the x cubes, x squareds, x's, and then the constants. Everything stays nice and neat. It's extremely important for these problems to stay organized. So keep your paper nice and neat, and that might help you find the correct answer. Okay, doing another example here. This time we have x cubed plus 4x squared minus 3x plus 5. And that's divided by x squared plus 3x minus 2. Okay, now, even though there's 3 terms, we have a trinomial here, the work's still the same. I still care about those first terms. So I'm thinking x squared times what gives me x cubed. Okay, I'm just going to multiply by an x. 1, 2, 3, 1, 2, 3. And again, everything has to line up. The x is going to go above that minus 3x there. Distributive property, a little bigger this time because there's more terms. X cubed plus 3x squared minus 2x. Okay, now again, the first term should cancel out, but that's it. There's other things that might cancel out, but it's not a guarantee. But the first term has to cancel out. X cubes cancel out. X squared minus x, and bring down the 5. Okay, I'm going to do my setup again. X squared times what gives me x squared. Well, x squared times what gives me x squared? It's just going to be a 1. So my 1's going to go above the constant. So I have x plus 1 up top. Distributive property, I'm hoping we can get through this one pretty easily. You're multiplying just by 1. X squared plus 3x minus 2. X squared plus 3x minus 2. And again with our subtraction, the x squares cancel out, which is exactly what we want to happen. We have negative 4x, negative x minus a positive 3x gives us negative 4x plus 7. X plus 1 plus negative 4x plus 7 divided by x squared plus 3x minus 2. So again, a little bigger problem because we had a trinomial on the outside. We were dividing by a trinomial. We still had to do the setup 2 times, and it's the same setup. We figure out what we're going to multiply by, distributive property, and we set up underneath to do our subtraction. Okay, so it's the same steps. Make sure you remember how to write your remainder. Okay, now this last example, I'm not actually going to multiply it through, but I want to show you of a situation that might come about. We have 4x cubed plus 2x plus 3 divided by x plus 2. Now the issue with this is, look at what we're dividing into. 4x cubed plus 2x plus 3. It skips the x squares. It's missing the quadratic term for that would go in that polynomial. Now that causes an issue because everything needs to line up nicely. Not having that x cubed is going to cause you some problems. Do you have to put this in here? No. But putting something called a filler will help solve that problem. It's a space holder. So we're going to divide by x plus 2. But now on the inside, we're going to put that x squared term in there. Okay? So everything's nice and neat. 4x cubed plus 0x squared plus 2x plus 3. That filler there is now going to make everything line up nicely like we always want it to. Okay? And having 0x squared, it's not a real value because anything times 0 is just going to disappear into 0. So no matter what we plug in for that x, it's not that big a deal because it takes care of itself with the 0 as a coefficient. Okay? That value is called the filler. It fills the space where we're missing that value, and everything will still line up nice and neat. Okay? So it's very important that you think about those and look at the problems and put in fillers where they're needed. Okay? So that's long division. Okay? Make sure you go back, look at those examples, follow the steps. It's very procedural. Follow those steps to get your final answer once you have your long division.